Let's take a look at science and how it works, guys. So our objective, as you can see here, we want to be able to define science. What is it? We want to explain how it works, and we want to know the difference between a hypothesis and a theory. So pretty straightforward material here today. Just a few little lecture notes. Um, if we were to look in different textbooks or use Google to try to find out what science is, if you Google what is science, you're going to get 10 million different explanations. And usually those explanations are specific to some particular area of science. A lot of you guys told me that science was the study of life, uh, or the study of the universe, or how things work. Yes, all of that is part of science, but none of it really encompasses it. So let's use a definition that is actually quite simple. It all boils down to trying to find out what is true and what is not true. Um, so science is, at least I think, a good definition of it is that it is a methodical search for truth. So if an individual was a biologist, a life scientist, then they're pursuing truth about life. What is it? What defines it? How does it work? How does it change over time? The same can be said for an astronomer who is a scientist who studies the universe. They would be looking for the truth about the universe. What is it? What is it made of? How did it originate or evolve over time? What is the possible future? How does it all work? So, at its heart, science is a methodical search for truth. And of course, if something is methodical, it follows a specific method or procedure. And some of you may already begin to realize we're talking about the scientific method. And the scientific method is really a good explanation of how science works. And just like the definition of science, how we could search the internet and find 1,000 different definitions for science, we could find a lot of different explanations for how the scientific method progresses. But generally speaking, it will follow a pretty specific procedure. So, science will begin with some point of interest or um, probably problematic interest or some endeavor to learn. Perhaps a scientist has observed something they don't understand. Um, or perhaps a scientist has a question that they would really like to have answered, or some particular problem that is in need of a solution. Hey, we could add to this list, but this gives you an idea of where the process will begin. Something falls from the sky. Hey, what was that? It's an interesting observation. How did that happen? That would be a question, or it might fall on my house. That could be a problem. So you get the idea. Some point of interest to start this procedure, and then a scientist will look into it first. If they see something of interest, they have a problem that needs to be solved, a question they want answered, they're going to study it. They're going to research it. They're going to browse through professional journals. search the internet to see if anybody else has answers or solutions, because there's really no point in undertaking a scientific investigation if somebody else has already done that work and figured it out. Um, Once this is done, and if this particular problem hasn't already been solved, then the scientists may want to hypothesize. And a hypothesis is interesting, guys. It has to have some very unique characteristics. First of all, it must be testable. So what is it? Um, well, it's essentially a guess at an answer or a solution. So you have seen something, you try to guess how to explain it, or you try to guess at the answer to a question or the solution to a problem. But the key is that you have to be able to test it. If your guess is wrong, you must be able to prove that it's wrong. So a hypothesis then is a testable solution. Um, so let's put that down here. A hypothesis is a testable solution or answer or explanation, dot, dot, dot. Um, Again, the key is that it is testable. If you can't test it, it's not a hypothesis and it's not science. It's just a wild guess. Everybody has wild guesses. In order to be considered scientific, it must be testable. So if your answer is pixie fairies made it happen, that is not testable insofar as I can tell. So that would not be considered science. That would be considered, mythology or goofiness, or what have you. Um, but once the scientist has made the hypothesis and it's testable, then they're going to want to test that hypothesis. And when we do that in science, that's called an experiment. This is a test of a hypothesis. And, really only one of two outcomes is possible for experimentation. Um, the results of the experiment will either support your hypothesis or it will not. If it doesn't support your hypothesis, that hypothesis is wrong. So if the experiment disproves the hypothesis, you really need to throw it away and come up with a new one. If it does not disprove your hypothesis, it doesn't mean your hypothesis is true. It just means that you haven't been able to prove it wrong. In which case, the results of that experiment really need to be shared. And scientists do this by publishing. Um, In other words, they spread the word. They tell others. And there's a couple of reasons for that. The first one is any procedure in science, any hypothesis that is tested must be duplicated. If others can't duplicate the experiment and get the same results, it is not valid. Um, And another reason is because other scientists may come up with a better way to test that hypothesis or other ways. So that's the purpose of publishing. They literally write up their experiment and have it printed in a journal that professionals in their field will take a look at. Um, Once that's done, others will experiment, and when the others do experiment, again, one of two outcomes is possible. They may disprove the hypothesis, in which case it needs to be thrown away and you need to start all over again. If, however, they are unable to disprove that hypothesis, it doesn't necessarily mean that it becomes something different, but it's possible. If enough time goes by, and enough scientists experiment, and let's say that your hypothesis has been tested repeatedly in a number of different ways by many different scientists over time, nobody can prove it wrong. It begins to appear as if it may be a valid explanation. Now, this particular hypothesis may gain in its powers of explanation if it becomes attached together with other hypotheses that have been repeatedly tested and never disproven, so that it forms a comprehensive explanation for some aspect of nature. It may possibly reach the point where it's considered a scientific theory. Now, a theory is not to be taken lightly. Um, let's talk about just exactly what a theory is. So a hypothesis, it's basically a guess at the answer, but it's a guess in a way that you can test it. And it's important that it be testable so that if it's wrong, you can prove that it's wrong. Um, the theory, on the other hand, is um, a well-tested hypothesis. It has never been disproven. If it had been disproven, it would have been discarded and a new hypothesis would have replaced it. So it's never been disproven. It offers, well, let's include its support. It is supported by multiple lines of evidence. And this is something really important about a hypothesis. It has, excuse me, a theory. It has a predictive capability. Um, it can make predictions that are accurate. If those predictions are not accurate, then something is wrong with that particular theory. So it's well tested, it's never been disproven, it's supported by multiple lines of evidence, it has predictive capability, and it leads to further research. Um, so a hypothesis is not to be, excuse me, a theory is not to be taken lightly, guys. Um, you know, you will hear people in their everyday language use the word theory. I have a theory about why, um, humans will never live on Pluto. I have a theory about why Buffy doesn't want to go on a date with me. Yeah, these aren't theories, they're just guesses or speculations. In science, a theory is something to be taken seriously. It is, it's predictive, guys. That alone is such a powerful statement. So, You may hear people use language around theory that is not really in line with this explanation. This is a popular one that I hear. Well, that's just a theory. Well, if you look at what a theory is, calling something a theory by no means is a put down. A theory is something that has never been disproven. So, you know, general relativity is Einstein's theory of gravity. That theory is more than 100 years old now. Nobody's been able to prove it wrong. Evolution by natural selection is a theory that's 150 years old now. So far, no definitive proof that it's inaccurate has been presented. And guys, scientists don't dig their heels in on theories. They are not the end of everything. As I note here, any theory is susceptible to being disproven. If it is disproven, it must be thrown away and start with a new hypothesis. So scientists never stop testing theories, and no theory is ever safe. Again, that evolution thing. I'm a physics guy, but hats off to biology. That is a stunning insight. Um, but it's 150 years old, and believe you me, there are plenty of people who want desperately to prove it wrong, but to date, that hasn't happened. If a theory is disproven, it is discarded. Are theories always correct? No, they are not. Um, they can be disproven. Isaac Newton's theory of gravity was disproven by Albert Einstein. So we never stop testing them. They're never safe. They're certainly not some sort of sacred thing that can't be questioned. Theories are meant to be questioned. They're meant to be tested. They are meant to have serious-minded people trying to prove them wrong. Uh, if that weren't the case, then science wouldn't work at all. So pay attention to the flow chart, and I think that we got out of this what we needed. Um, Email me, guys, if you have any questions about the material. And that's going to do it for this lesson.